Welcome back. In today's video, we're going to look at the three methods for solving systems of linear equations in two variables. We have graphing, substitution, and elimination. When it comes time for your assessment, I will not require you to use substitution or elimination. However, you want to get comfortable with both methods because some are more useful or more efficient in certain problems. There will be a question that requires you to graph a system of equations to find the solution. So let's look at one example of graphing. Remember that when you're solving a system of equation, you're looking for where these two lines intersect. That's what the solution represents. So a natural option would be to graph the two lines. X minus 2y equals 4, 3x plus y equals 5. First, we want to take these two equations and convert them to slope-intercept form, since that's our preferred method for graphing. So for the first equation, we'll subtract x from both sides. Negative 2y equals negative x plus 4, and then divide everything by negative 2. So the first equation in slope-intercept form, y equals 1/2 x minus 2. We'll go ahead and graph this line. Our y-intercept is negative 2, and our slope is 1/2. So we're going to go up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. When solving a system of equation by graphing, you want to make sure that you use the entire grid because you're looking for where the two lines intersect. If you only use a portion of it, you might miss that point of intersection. Now let's look at the second equation. 3x plus y equals 5. Subtract 3x from both sides. Y equals negative 3x plus 5. For this line, my y-intercept is positive 5, which is cut off, and the slope is negative 3. So we will go down 1, 2, 3, and to the right 1. Down 1, 2, 3, and to the right 1. 1, 2, 3, and to the right 1. And as we were plotting those points, we saw where those two lines intersect at this point right here. So our solution is 2, negative 1, written as an ordered pair. Now let's go into the algebraic techniques for solving systems. We'll start with the elimination method, which is also sometimes known as the addition method. The purpose of the objective of the elimination method is to combine your two equations to eliminate one variable. So we might have to modify one or both of the equations so that our variables have additive inverses. So my first equation, x plus y equals 11. My second equation, 2x minus y equals 13. When I observe the variables and their coefficients, y's are additive inverses. We've got positive y and negative y. If I were to combine these two equations, they would cancel out. So that's the variable that I'm going to choose. When I combine these two equations, we get 3x equals 24. I'm going to move over here. And that was adding my x's and adding my constants. When I add positive y and negative y, they cancel out. And divide both sides by 3, x equals 8. Now to find our y value, we're going to take that value of x equals 8 and plug it into either of my first two equations. It doesn't matter which one, both of them will work. So just using my first equation, x or 8 plus y equals 11, subtract 8 from both sides, y equals 3. So my answer, as an ordered pair, is 8, 3. Now this particular example was very straightforward, very simple because we already had the additive inverses. Let's look at an example where we don't have additive inverses from the start. 4x plus 5y equals 3, 2x minus 3y equals 7. To start, we want to decide which of these variables, x or y, we want to eliminate. Looking at the coefficients and the signs, I'm going to choose x because I can simply take this second equation and multiply by -2. And when I do that, I'll get -4x, which when combined with positive 4x is 0. So we have 4x plus 5y equals 3. My first equation did not change. And -4x plus 6y, make sure you distribute across all terms, equals -14. Being careful of the signs. When we combine like terms, 5y plus 6y is 11y. 3 minus 14 is -11. Divide both sides by 11. Y equals -1. And now, just like in the previous example, we're going to take that solution for y and plug it into one of the original equations to solve for x. I'm going to use the first equation for no reason other than it's first. 4x plus 5y, and I forgot to substitute, so go back to that. 5 times -1 equals 3. So 4x minus 5 equals 3. Add 5 to both sides. 4x equals 8. Divide both sides by 4. X equals 2. My solution, written as an ordered pair, to -1. Now let's shift gears and talk about the substitution method. The substitution method, our objective is to take one of our original equations and isolate one of the variables. Once I have one of the variables all by itself, I can then substitute that into the other equation. So 3x plus 2y equals 1, x minus y equals 3. I want to look at my two equations and decide which equation do I want to work with to isolate which variable. I'm looking at the second equation, x minus y equals 3, because x and y have very simple coefficients, 1 and -1, which will make it very easy to solve for them. If I look at the first equation, 3x plus 2y equals -1, if I try to solve for either x or y, you can probably tell that you're going to end up with fractions, which you don't want to have to substitute into another equation because then you just continue to work with fractions. So we'll work with the first equation and we're going to solve for x. Now I chose x because x has a +1 coefficient instead of a -1. If I chose to solve for y, the last step would be dividing everything or multiplying everything by -1. So we're going to add y to both sides, and this gets x by itself. Once you have x by itself, you're going to take that and substitute it into the other equation. Notice I began working with equation 1 and I began working with equation 2 and I substitute back into equation 1. So this looks like 3 times, instead of x, 3 plus y plus 2y equals -1. Distribute the 3. 9 plus 3y plus 2y equals -1. I'm going to subtract 9 and also combine like terms all in one step. So we have 5y equals -10. Divide both sides by 5. Y equals -2. Now when we were using elimination method, we took our first answer and substituted back into one of the originals. You can still do that with substitution, but a really good option would be to use that equation we solved for in that first step, because x is already by itself. So x equals 3 plus -2, which is the same as 3 minus 2, or 1. So my solution as an ordered pair, 1, -2. Let's try one more with substitution. 3x plus 2y equals 4. 2x plus y equals 1. Looking at our two equations, it's clear we want to use the second equation because y has a coefficient of 1, which means it's going to be really easy to isolate. Y is equal to 1 minus 2x or negative 2x plus 1. It doesn't make any difference. And we're going to take this value of y and substitute it in for y in our first equation. So we have 3x plus 2. Instead of y, we're going to substitute in negative 2x plus 1 equals 4. To solve, distribute 2. 3x minus 4x plus 2 equals 4. Subtract 2 and combine like terms at the same time. 3x minus 4x is negative x equals positive 2. Divide both sides by negative 1. X equals negative 2. Now this first solution we get, we're going to then plug in to that equation we found in part 1. Plugging in negative 2 for x, we have negative 2 times negative 2 plus 1. Negative 2 times negative 2 is positive 4 plus 1 is 5. So our answer in an ordered pair is negative 2, 5. So that gives us a few more examples of solving using substitution and elimination and a quick review of graphing linear equations to find the point of intersection. One of the things I want you guys to observe in those 5 examples we ran through, the solutions ended up being pretty nice and pretty integer answers. Now that's not always going to happen, but a good red flag when you're solving and you start getting really crazy fractions like 63 over 17 or something that is just completely off the wall, stop where you're at and go back and check your work. There are a lot of places within these problems where we can make really tiny careless mistakes, dropping a negative or combining incorrectly or not distributing all the way. When we make those tiny little mistakes, it's going to affect our answers a lot. So when we start getting answers that are really, really crazy, stop where you're at, go back and check your work. Now, if you check your work and you don't find any mistakes, then that particular problem has a really strange answer, okay? Not a pretty fraction or pretty integer. That's okay, but you want to make sure that you don't carry through incorrect answers if you don't need to. Again, to remind you guys for your assessment, you're not required to demonstrate substitution and elimination. The questions will just ask you to solve them algebraically, so you can choose which method you prefer. Substitution, a lot of students really like it, but be mindful when you have a system that doesn't work nicely for substitution, elimination is usually the route you want to take. To identify that, if you're starting to get a lot of fractions when you're solving for a variable, you may want to switch to elimination. But if a problem is clearly set up for substitution, go for it. As far as the graphing, there is a question where you're going to have to graph. Remember that graphing linear equations is a really important skill in this course, so we want to make sure that you guys are strong with graphing lines. I demonstrated using slope-intercept form. If you want to graph another way, making a table of values, that's fine. So go ahead and practice these. Our next video, we're going to look at how we can take these skills and apply it to problem solving. We'll see you next time. Thanks.